data science SIG or special interest group, typically on the fourth Monday of the month. We can also offer some networking, job hiring announcements. If you have any job hiring announcements, you can post them into the chat and other people can see them. And then if you want to coordinate afterwards, I have an announcement. I'm hiring a senior data scientist. So let's see, for some upcoming ACM webinar events. So we have a color code on the bottom right, green for data science, black for general computing, and red for SIGGRAPH. So on Thursday, May 26th, we have Silicon Valley ACM SIGGRAPH, Character Creation Revisited by head of Ziva at Unity. Then Monday, June 27th, we have a webinar on AI-based flare monitoring to reduce global warming. So I'll be the speaker on that with one of the people on my team. So we're combining a physics-based model on gases along with a vision model that's looking at the flare and the smoke coming out of stacks at a natural gas processing plant. So this is a product that we've deployed a couple of times and we're working on a patent application for. Then on Wednesday, June 1st, we have making of the Mitchells versus the Machines from CG supervisor of Sony Pictures ImageWorks. Also on, and then that's repeated on here. Friday, June 10th, there's also an ACM 75th anniversary celebration at the Palace Hotel in San Francisco. If you want to find out more details, let us know. We found out by an email from the ACM headquarters in New York, but we could share that with you. So I think they have limited space. So use the chat in Zoom if you have questions for the speaker. I'm the moderator. I can bring up and ask the speaker questions. We can ask a few questions during the talk and then more questions at the end. Also, the chat you can use for job announcements. And I'll post my job URL there. Anybody else is willing to, it's available for anybody else to post it there as well. So today's talk is AI-based computer interface for accessibility. And Henri's a volunteer at AbilityPath, a nonprofit for services to people with disabilities. He recognized a need of people being able to use technology. There's a high level of motor control prohibit many people's access. So he wanted to simplify computer interfaces with gestures, capture signals on a webcam, and he'll show how the data process is fed through two different AI models. One is hand landmark positions, and another is gestures from those landmarks. And he made the project open source, available for others to use. He's a sophomore at Kehillah High School. He's interested in computer science, AI, and math, a member of USA CO and volunteers at AbilityPath. He likes experimenting with RNNs and CUDA-C lately. Avid guitarist, sailor, and potter. So please help me welcome Henri. So I'll stop sharing and you can share.
Yeah, well, thank you. I'm gonna share my screen. I can go here. Okay. Well, welcome and thank you for joining me tonight. Okay, I can do, yeah. So welcome and thank you for joining me tonight. I have to say I'm very glad this is happening on Zoom. Like many people right now, I'm homesick with a fever. My dad has COVID, so excuse the occasional cough. But this is AI-based computer interface for enhanced accessibility, and I'm Sayag. So, as to what we'll really be doing for the next hour or so, I'll start with a small introduction, explain a bit about who I am, my interests. Yeah, I'll then explain my motivation for trying to address the issue. I'll also define the issue. I'll explain why it's important, how I found it, and that sort of stuff. I'll then explain the difficulties and technical challenges that surround the problem and the ones I faced, and how it sort of complicates the problem. Then I'll go over my plan and idea for a solution, each step and each element of it, Then I'll show how I implemented it with a live demo. I'll go over my solution, a bit about how it works, and interact with it. I'll then show the sort of data and structure that I used to feed the model I made. And I'll go into a conclusion, and I'll explain a bit of what I got out of it and the further steps and that sort of things. And then I think a bit of Q&A. As I said, I'll start with an introduction. So again, I'm Henri Sayag, a current sophomore in high school, and some of my interests include math and computer science. So, about my motivation and problem definition. Well, while volunteering at AbilityPath, a nonprofit serving people with disabilities, I noticed a major problem some people faced was not access to physical technology, but being able to fully use it. Sort of major bottleneck and issue is the interface, how one really communicates with the device, with the technology. It seems slightly unreasonable to assume everyone can control all of technology in the internet by moving their finger over a 15 centimeter square component, that is a trackpad, or move a mouse in a precise and well-defined way, or pressing on a key. Technology relies on a lot of fine motor control and dexterity. As I'm also going to be talking about fine motor control and dexterity, I would like to mention that dexterity is a subset of fine motor control, specifically relating to interactions with the hand. A bit about my motivation, why I chose to try to do something about this problem. Well, I think it's really only fair that everyone has a simple access to technology like you and I benefit from, and I want to be part of that process and hopefully improve access for others. So, just a bit about a bit more about the sort of population and sort of people this would kind of apply to. So according to a Canadian survey on disabilities, an average of 3.5% of Canadians have some sort of dexterity-related disability. The prevalence also increases with age. Yep, I have a graph on that. Although dexterity-related disabilities do correlate with other factors, these various metrics show how it can lead to a disparity in access to higher education. And well, due to the increasing prevalence of technology in schools, the dependence on the interface to just be able to effectively use it, at least a pre-COVID study, and I emphasize pre-COVID as the number has only dramatically increased, and this is a sort of lower bound. But a pre-COVID study showed that fourth graders spent on average 14.3% of their school day performing fine motor control activities, specifically fine motor control activities through technology, which is quite a lot, and especially for a pre-COVID study. But about the current solutions. Well, as technology becomes more widespread, the question of accessibility becomes more and more prevalent. How do you modify or adapt the concept of service to be available to a maximum of people? So depending on the different abilities, many technologies have been developed, specifically relating to motor control and dexterity. For example, an oversized trackball mouse, adaptive keyboard, those are the two images shown above, or I guess to the right. Voice recognition technology and eye tracking. Those seem to be the most prevalent solutions, or solutions to the specific disability. Yet most of these come with the disadvantage of being either expensive, unnatural, slow, or require complex input and strict technique. I mean, the goal is not to have people pay for something that's already free. So, and especially with sort of products marketed towards helping people with disabilities, they're often more expensive, harder to get, and slower and clunky. And technology such as eye tracking requires complex inputs, and it requires it's usually slow, as conveying information in a fast way through eyes, and analyzing that is quite hard. The voice recognition. Most languages are quite complicated. Differentiating between something like "Hi Siri," "Hello Siri," "Hey Siri," "What's up Siri," all these sort of you need a very usually narrowly defined input, or what are chosen, and thus the very specific, and it requires a lot of time, verbosity, and it generally has problems. Others have tried to address the accessibility problems surrounding neuromuscular diseases, or also people who may lack hand muscle control, by using facial expressions captured by a camera to control a game. Yet there is an overwhelming population of people who have trouble with fine motor control, but yet won't really benefit from a fairly unintuitive, unnatural form of interface. Controlling a computer through facial gestures is quite hard when fine motor control is what you're struggling with. Devices such as the Microsoft Kinect did offer a possible solution, but then again it requires additional and dedicated hardware, so it's less portable, and you're paying for what other people have for free. A webcam, hand-based tracking games, and I'll explain why I'm looking at games specifically. But generally, they all seem to require at least one of the following: additional hardware, specific props, usually to improve detection, or a paid software. All of these just further reduced accessibility. It makes it seem to be something that was done after just a sort of check a box, and that isn't really as embedded as it could be. And my goal is to create something universal that could work for anyone, and that doesn't just like spread the sort of divide. I'll also be talking about I'll be talking about why I'm focusing on games in the next slide. Okay, so the challenges and difficulties. Well, these are more of the sort of goals that I've given myself to try to follow, and try to just to make sure it's as universal and as accessible as possible. So I wanted to solely use a laptop webcam as the source of input. The goal of this was, well, firstly, it's worth mentioning, I'm going to be focusing on using gestures. I'm going to be talking a bit more about that later on, but I'll be using gestures as the source of input to control the computer. So I want to solely use a webcam to minimize the cost, as it's embedded in most computers since a while, a couple decades. And it's going to maximize accessibility. It's something that already comes with most computers, and so they're not paying for anything extra. The problem is that means dealing with a single stream of 2D images from a sort of front-facing view. So it's hard to get spatial data. Just like things can get covered up, and it's hard to. There's problems that come with it. I want it to minimum in speed and reactivity. I mean, it should run at a reasonable speed and not require. Should run at a reasonable speed to not slow people down, to be as reasonable, as effective as any other technique, and just be as direct as possible. Also, making a point to make it not require unreasonable processing power or resources. So most of the development was done on a 2017 laptop with 8 gigs of RAM. So it's not made to run on a supercomputer. It should run on old technology without struggling too much. It should be consistent and reactive. That's a big thing I want. Mice, trackpads, keyboards, they're very good at being reliable. They work quite well. When I press on a key, I know it's going to get pressed. I don't have to do it 3 times. Someone can type at 200, 100 words per minute, and it works quite well. So I want a system that works well and is fairly scalable. And it should be reactive to provide a good experience. Accuracy. I mean, it should be able to comprehend the intentions of the users. It should be fairly good at detecting gestures, at doing what the user wants it to do, and it should accommodate a wide variety of users. Since I'm doing my best to make it as universal and as accessible as possible, it should at least be moddable or usable to a maximum amount of people. Finally, I wanted to depend on free and open source technology. It should rely on free software because, again, I don't want people paying for things that others have for free. It should be free, and the point on open sourceness is it should be as transparent as possible, and people should know how it works. And a big thing is that people should be able to modify it, create whatever they want out of it, and sort of kind of use it to address all sorts of different stuff. It's a bit on the goal. So the reason I chose gestures is because I wanted to avoid very specific, nearly borderline unnatural forms of communication. And I wanted to do something more intuitive and sort of broader. I also chose to make a game because I've also been looking at games, but I'm choosing to make a game specifically as a sort of demo. It's specifically a car game because of sort of the sort of intuitiveness and popularity of the input gesture. What do I mean by that? I mean steering. It's essentially you have your hands on a steering wheel and you can sort of steer. Most people know how cars work, at least at a high level, and it's not complex inputs with crazy keyboard inputs and stuff. And secondly, because games rely on pretty tight feedback loops and high amount of stability. You have to be able to get in input at 30 frames per second or a high at a high rate. And I wanted to show this sort of technology is able of achieving those kind of marks. So yeah, dealing with high-speed input. So a sort of big element that I don't really mention in the slide, but I want to make a note of is it's quite hard to balance performance with accuracy, and that's some sort of one of the big things I had to deal with. So how I really try to address this problem? Well, I split it up into a set of steps. Well, to extract gestures, first you have to get webcam data, extract hands, then off those hands, probably extract hand landmark positions, and from that, from those hand landmark positions, try to classify different gestures. The problem is, usually to extract a hand, there are analog techniques, but generally deep neural networks work better. The problem is I do not have millions of images of annotated hands with different hand landmark positions. So I've decided to use MediaPipe. MediaPipe is a free and open source collection of it's a collection of computer vision models, and they had one that was able to identify 21 points on landmarks on each hand in sort of pseudo 3D way. Why I say pseudo 3D? The depth is kind of the depth is estimated. But yeah. And then, so really what I had to deal with was detecting different gestures based off hand landmark positions. And that meant creating a data set of different gestures, training a classifier on it. And then I had to create and run a game off these inputs. So yeah, I have a flowchart here that explains a bit of how I did it. So yeah, webcam. I use OpenCV to do a bit of image processing to clean stuff up. Then pass it through MediaPipe, TensorFlow, and then I'm using Panda 3D. It's an open source game engine to manage the game. Yeah. So a bit about how I did this. Is the code popping up? Well, I think so. Well, firstly, I had to implement MediaPipe. But I separated it into a sort of set of tools. So to create the data set, I have a data set creation system, but the idea is I'm going to run this, but I can run MediaPipe, and then I think it's better if I just show it.
If you like, you can just show the MediaPipe webpage. It shows some of the examples, or run it, whichever is easiest.
Yeah. I mean, I have this demo. I might do both. But essentially, I can run MediaPipe. It runs quite well. The idea is, if I put my hands up, I can identify hand positions. So there's 21 of them on each hand. I can detect multiple hands. Currently, I have it set at detecting a maximum of 2 hands, because, well, there shouldn't be more than 2 to control a steering wheel. But the idea is, I've annotated them and drawn them on top of my current hands. But I can essentially put my hand in a certain pose, press on a key, and it'll save it into a file according to the different keys. So for my car game, I rely on a sort of like holding gesture for the steering wheel, and then I extend a finger when I want to indicate acceleration. I can also have different gestures for different things. I don't know, going into reverse, braking. There's all sorts of things. I can have different key presses that map onto it. So I created a data set of those.
What kind of frame rate is that running at?
So currently with Zoom, it's not running great. I'm getting, I also think there's slight bugginess, but it's probably about 15. I gotten up to 30. I think I'm also running unnecessary stuff. But it can run at nearly 30 frames per second on most computers. Yeah.
Oh, good.
So in terms of information I'm storing for each 21 points on each hand, a joint ID, which is a number between 0 and 21. I can actually I'll keep this running so I can show what different joints correspond to. But the 0 joint is near my wrist. It's that bottom one. And then so I stored the joint number, as well as whether it's the left or right hand, in a position vector, in XYZ. I also have simple sort of optimization ways to clean up. I use relative positions, so based off that 0 point. So then the main thing I have to manage is rotation is in depth. That's the main things the model has to manage with. The labels are stored in the different files. The file corresponds to the label.
Question for me: does it have knowledge of palm forward or back of hand forward to the camera?
Yeah. It won't. You can extract it as you have a pseudo 3D data on it. At one point, I tried to model a 3D hand based off the points, and it works quite well. So yeah, you would be able to notice that the actually I don't.
Well, you could probably infer it just from the right hand side of the screen and which way is the thumb on that hand.
Yeah.
If the thumb is towards the center of the body, it's palm forward. If the thumb is away from the center of the body, then it's back of hand to the camera.
And because
that'd be an easy way to do it.
Yep. Yeah. Technically, if you were to put your hand, but you can infer it. So I also then clean up the data, and separate it into I merged it into one big file. Main thing is I switched to I clean up the data a bit. I'm rounding the Z, because it's an unreasonable. I was having problems with that, and it generally cleans it up. I also shuffle it. Some of the big things I do is I add the labels and I split it into a test and train data set. Currently, I'm using a 90 to 10% test train ratio. So that's how I manage that, and I just put it in a big JSON file. I mean, it looks, I don't think it's very useful to show it, but it just looks like a big file with all the labels. Then in terms of train a classifier on it, well, I just unpack the data I've acquired. I clean it up a bit because sometimes it detects multiple hands when there's only really one hand. So I generally clean that up. I split it up into batches and then shuffle it. Yep. In terms of the model, it's a simple classifier. So this should be 84, but the idea is I have 21 points. And for each 21, I have four data points. So it's 84. I then go to a 40 neuron layer, dense again, with ReLU and then ton H. And then I just move on to a softmax, just to make sure that either it's right or it's not right. And so I just force that on. I compile it and train it using Atom. And then I just compile it into a more sort of executable form so that the performance is better. Those are the main things surrounding the model. A bit of what this looks like when everything is combined. First, I unpack the model. I have an implementation of media pipe again, and I also calculate steering angle. And I'll show how that works out. Yeah, so the idea is, it takes a second just to first load the model, but my idea is I'm using the joint landmark on my index finger to detect angle, which is shown in red at the top. And the model, I mean, it works quite well. And I can sort of detect how the position works, whether my finger is extended or not. It's slightly overkill to be detecting whether a finger is extended or not with the whole model, but the idea is I'm gonna add different gestures that correspond with different things, and to have more complicated and useful inputs.
Did you come up with an easy to distinguish set of alphabet of like a dozen hand gestures that are easy to separate from each other? I'm thinking like when people spell out words, they say Alpha Tango Bravo instead of A and T and B. You know, using the words makes it easy to distinguish. So, but then also something that's kind of comfortable or makes sense in a game that's intuitive.
Yeah, especially with I mean, I'll show. I made a game. I'll show the game, but it's quite intuitive. There are problems with the game, but yeah, the interface works quite well. Yep. So a bit about the. Am I still sharing?
Yes.
Another big thing I wanted to work on is making it as easy to use as possible. So I have a GitHub page for it, but the idea is this is the game version, but I can simply download the zip for it, and then unpack it. It'll take a second, but it's also pretty small, but I can essentially download a new version every time. It's because of the amount of libraries it uses. I'm currently using I have a YAML file that through Conda, it'll manage all of the libraries, so that's fairly it's fairly streamlined. I'm working on making it more compact and more compiled and sort of more streamlined to run and all, but it's fairly lightweight and stuff. So I currently have 2 versions of the game. The main difference between the two is the sort of the terrain that I will interact with and move through. They are both sort of suboptimal. The first one is a height map that I mainly used while development. And then I have a more complex terrain, which is a GLTF 3D model that I made in Blender. But because the model it'd be complicated to drive through in real life. The edges are it's too steep. The edges are too sharp, but I can interact with it. Yeah, it's easier to drive through the first one. I also have a video of the second one, so I can show both, because Zoom does affect the frame rate, and performances. But yeah, I'll go over that. Okay. So a bit about what we're seeing right now. In terms of the design choices, these weren't maybe the best, but this is the inside of a car. The big black space, it's slightly unnecessary, but it's the inside of the car. I was planning on adding a speedometer, and it's where the hands are mapped onto. But and this is a height map, so that's a wall, and the floor is the floor. The blue is also the blue is the color of this sort of sky map, or I guess sky color. But the idea is I can put my hands into the camera's field of view, and they are mapped onto the screen. I can just like grab onto a steering wheel, and kind of based off the angle of my steering of my hands, drive the car. So it does accumulate angular velocity, and it's annoying to change direction you're going in, but it's fairly doable to navigate through. It's a bit slow, but essentially if I turn my hands that way, I actually think the video is reversed, but just by turning my hands, I'm able to drive this sort of car through this environment. And of course, there's interactions between the car and the walls. So if I were to run into a wall, the car slips up onto the wall. It's a fairly rudimentary demo. The version with the actual terrain, I'll do it in live, and I'll show it running a bit better through a video. But the idea is, and I'll explain a bit of what we're seeing again, because the graphics aren't as intuitive as I could have been. But again, this is a car. Again, the hands will be mapped onto this. The yellow is a speed bump. So I'll drive over it while trying to, and the car should interact with it. And the brown is a ramp. Yeah. Oh. But yeah, so it does have, yeah, does have performance problems, but generally fine.
What's happening when one of the hands goes red in the simulation?
Yeah, so the red indicates whether or not it's detecting the hand gesture, the extended finger. It also has a slight delay, so it might turn green when it's still red. And it depends on factors like angle and stuff. Yeah, as the model is more complex, and Zoom is taking quite a bit of resources. It's a bit laggy, but I can generally drive through it in turn and interact with the walls. I can show kind of what it looks like when it runs better. This was also just filmed. This was a screen record, but yeah, I'm sorry that Zoom messes with performance, but yeah, it runs nicely when when I have access to actually decent performances. But
I suppose if you wanted to, you could post some of your videos on your GitHub as a link
yeah,
somewhere, and then people could look at it without the Zoom slowdown.
yep. But yeah, it runs. You can interact with stuff, and I mean, it does the intended goal. Yeah. Okay, back to the presentation. Okay, spoke about the data. I talked about it a bit, but what the model is actually fed is it's essentially just a long it's a long vector with the joint, so a number from 0 to 21 hand, 0 for left hand, 1 for right hand, in relative XYZ positions. This is multiplied by the 21 points and by the 2 hands. Yeah, so that's generally what it gets. Here's, I think, a bit clearer screenshots of what the points correspond to. So yeah. So, well, in conclusion, yeah, it is about 740. Well, the project turned out as expected, as in that the prototype achieved the desired features and can offer an enjoyable game experience. It solves, hopefully on a small scale, part of the presented societal issue with accessibility, or presents itself as a solution. So one of the sort of unexpected features of the prototype, or not feature, one of it unexpected or unexpected how big of an impact it would have was the quality of the asset, and I say that as asset as in 3D models and the model of the neural network for gesture analysis and media pipe. Is the overall performance of the game based off the assets? Well, the more detailed to make the complex models, the more accurate the model is, or the more complex its architecture is, the slower the game would run. So I had to sort of limit the complexity of the models, and I had to find a sort of balance between complexity, speed, accuracy, while keeping the game interesting and motivating. I also learned a lot of different things that could help me bring it further. Well, firstly, it kind of serves as a proof of concept, a way to show the viability and sort of powerful potential of the crossover between AI-powered computer vision and accessibility, which has applications inside of the game industry and sort of beyond. Also, a prototype of game which is active to development could become a real tool available to the public, promoting accessibility and inspiring others to sort of shrink this sort of divide. And through my collaboration with AbilityPath, we intend to use this game or see how this game could work with this sort of population, and incorporate their feedback into including the game. Also, as a note, I realized this a bit late, but having a game purely created for this the reason I tried to do that is because I wanted it to be really I wanted the interactions between the programs to work quite well and for it to be built for it essentially. Problem is creating a game that runs at actual decent performances with complex physics it isn't easy, and I think it might be better. I might try making modifications for current games and have this run on top of it. Also, a sort of second thing I got out of this presentation is really how like associations like the ACM, universities, and all sorts of people have allowed me, some high school sophomore, to use these tools without needing a PhD in it, thanks to all this open source technology and free stuff. And I really want to thank all of you. I find it really great, and yeah, I would like to see how all of this goes. Yeah, so I think now we go into what I had planned to be Q&A. So if there's any questions, things we want to look more at or see, I'm open to that. Yeah.
Any questions from the audience? So one suggestion, if you're working on speeding it up, you can, and you're running on a laptop that runs an Intel, you can run it through OpenVINO. It's an Intel library, and that can speed things up by factor of 3. I pasted it in the chat window if you want to copy it out of the chat window. And so if you go from like 64-bit weights down to 16-bit weights for quantization, that's usually doesn't impact the accuracy too much, and is fairly good at speeding things up. There's different levels of quantization you can play with. You could also try dropping the resolution a little bit in resizing before you put it in. And then some Intel processors have a built-in GPU. And so by default, OpenVINO may not be using that, but you may want to look into some GPU use, and that could still stay with your theme of not having extra hardware cost. But if somebody has like 11th or 12th generation Intel, then it'll have that newer GPU in the chip.
Yep, so thank you. I'll look into that. Yeah, that was one of the biggest things I had to struggle with. But yeah, hardware optimization stuff.
Would it be any faster if you dropped some of the dots, or it's going to do the same amount of processing no matter how many dots? Like, every other finger or something. I mean, you're capturing the general gestures, a hand open or shut. But if you have certain fingers, keep the thumb and the index and maybe something else.
Yeah, the model is fairly wasteful. I was just wanting to look at the sort of upper bounds of performance if I wanted to have different, more complex gestures. An extended finger is not too complicated, but yeah,
Okay.
if I definitely want to finalize it, that would help a lot.
Oh, we have a question that came in on chat. Edward said, in the past, I worked with people that had problems with gross motor control. Some could not walk, but they could control their limbs somewhat at the arms and wrist. Do you think that this project could be adapted to give those people an interface? So, I think this gets back to that original site that you were looking at, the media pipe, with a pose gesture that might do arm and hand.
Yeah, that's definitely I think I was going to mention that. I don't know what happened, but MediaPub is a very nice library for that sort of stuff. They have all sorts of tracking, up to like eye tracking and limb tracking. I don't know if I mentioned it, but since I have access to quite accurate data on position and stuff, one of the original ideas was like making a fitness tracker that would depend on like limb movement and identifying different exercises. But I have through these tools, I have access to a lot of different data, so it could be adapted. For example, for like stroke patients and stuff, they usually start at shoulders and like work down to the hands when trying to do rehabilitation stuff. So I was probably looking at making new versions that depend on like shoulder movement, shoulder rotation, and shoulder up or elbows. But there's a lot of possibilities, and it's a lot of potential. Yeah.
A comment from SR on the chat. You might use the nodes of the finger internally, but the display could suppress them and just have lines for better performance.
Yeah.
A suggestion I have on the pose and hands is there could be a market for people that go to physical therapy and they have to do certain hand exercises or foot exercises or stretching. And the physical therapist needs to look at them and see if they're doing it right. Or a person may need to look at a mirror. But if you have something that's for very specific moves, and then you can tell the person where they're deviating from the structured moves. But there's at medical sites, there's different PDFs you can download showing the types of moves or the types of stretches you have to do. And there would be a larger population for that with very regulated kind of motions to go through.
Yeah. Yeah. I was looking at similar stuff when I was prototyping like uses that I could do with the gestures as sort of demos. But yeah, just generally, I have access to all sorts of informations, and there's really all sorts of stuff that could be done.
Yeah,
it's things I'll be looking into.
Yeah.
Oh,
if you
yes.
like.
So GitHub, I will get that ready. I think the easiest way for the GitHub, because part of it done on a school account, but I'll share a link in chat, and maybe it can be put in the description of the YouTube. But
yeah, I mean, on the meetup site, there's a discussion session at the bottom. And if you want to post a link to the PDF of your slides or a link to your GitHub, you can post it there.
Yeah.
On the meetup site for this event.
I'll do that. So this is the current current link I'm using for the GitHub. The README still has I'm updating. I haven't pushed all the new changes. It has issues, but I'm planning on fixing that up.
If you want to, or when you get a chance, you can come back and post it to the meetup site, and there's a discussion section at the bottom. Let's see, SR had another comment. For such medical use, data can be post-processed and fed back to the user for subsequent sessions. So something I might interpret is, especially if you're working with a physical therapist, you try some motion 8 times, and then they pick out the best one is number 7. So then if you save that, then that could be saved and just played back. And then later on, if you had a difference from the current one to the staged one, that way you wouldn't have to try and build something that does all possible PT exercises in the planet, but just compare to a reference one.
Yeah. I could probably even improve data set and stuff. It's surprising and also interesting how I was looking at a lot of things like this when originally thinking about this. But for example, again, the fitness tracker. Since I've a lot of access on different motions, I can give them data on what they lasted and turn it into sort of like an interactive game where you try to beat a record, or again, you did it this way then before, and then it's a sort of it's just a more interactive way of improving and doing all sorts of stuff.
Okay,
that's definitely a big thing I am going to look at it. Yeah.
Okay. Let's see, Edward commented, are you planning on taking some college level classes early? I'm sure local universities would be interested in having you attend. And then Carl said from the Q&A in Zoom, it'd be great to expand this as a generic replacement of the mouse. or moving around.
Yeah. I'm currently taking AP classes, but as a replacement for the mouse, I was thinking about that. The current, probably the most limiting factor is the actual field of view of the camera. I I can only really go from you depending
Imagine
on
if
the
you had
configuration.
a top-down view on the back of the hand. So if you put the hand where the mouse usually goes, but then you have it on some kind of stand or tripod, looking at where that hand is, and the hand's not moving with the mouse, but it's moving within a viewable square or rectangle, then you could do gestures instead of the mouse movements.
Yeah. I was also gonna prepare for this presentation, but with finals and other things, I ran out of time. But for example, moving through a slide deck, I could have a thumb in a certain direction and be able to do that. There's all sorts of potentials to interact with the computer, moving through windows and all sorts of interaction. The mouse thing, that's definitely something that I think will become more and more prevalent in the future, especially with VR and stuff. Actually, a lot of the current work and stuff in this sort of gesture computer vision stuff is for VR, so that's interesting. Yeah.
Coach Antonio asked, how long did it take you to come up with such a model?
So for the actual model configuration, architecture and stuff, I went through probably 4, 5, 6 maybe different models. I was messing around with like formatting in a sort of 2D way and having convolutions and stuff. The main thing was performance, managing that in terms of actually training the models. I was surprised by how fast it is. It would take like an hour, 2, 3 hours maximum per model. The data set, as I can, because of relative positioning and stuff, it only really matters the rotation and depth. So I could essentially take a video of captures of different gestures and move my hand. I was able to get like 2, 3, 4,000 snapshots in 15, 20 minutes, which provides quite good sort of like base to train the model onto.
So the media pipe seemed to have a lot of pre-trained solutions. What was your additional training you did beyond what they had?
Yes, the gesture models, inferencing gestures from the hand positions. Yeah.
Oh, I see. So they had the hand model, and then you added the gesture inferencing.
Yes.
So did you come up with like a gesture A, gesture B, gesture C kind of thing? It was just basically with a hands on the steering wheels and rotating. So that was kind of hand on steering wheels was the gesture that you recognized. Is that the case?
In different things that acceleration and different gestures for different controls.
Oh, okay. So how many gestures did you end up having in your game?
Yeah. Currently, so for the data set, I think I trained 2 or 3 gestures. For the actual game, I'm only using 1, mainly because of performances and time. I was unable to implement all of them, but yeah.
Okay. Let's see. Tom had something from YouTube. Let's see. Lawrence, are you going to use this algorithm for medical reasons?
For well, so I did talk about like the fitness tracker and that sort of stuff. So in terms of, I think that the main problem with medical resources is I don't have the type of certifications and information to really make these tools, especially for medical stuff. But it's sort of like this definitely has potential to do that. I think it could definitely do it. I think I could.
Well,
I could
one
make
way you could
models.
get around that is you're not the medical professional. You just are the recording. And then, like I said, the professional has the patient do the gesture 10 times, picks out the best performed one, and then take that at home. And so the medical professional picks out what the right gesture is, the right exercise, the right stretch. And then when the person goes at home and they have to do their exercises every day for some time, then as they're doing it, if you can find some difference, like, no, I'm choosing to do gesture 5, which is a particular stretch with a leg. And then, or, leg, and then it kind of indicates if it's within a certain range, you get some good feedback and earn some points, gamify it.
Yeah. That's that's quite interesting. I think I'm gonna look into that. But yeah, I think these are definitely possibilities thing I can look into. I haven't really had time to look at the challenges that these things would entail, but yeah.
What neural net architecture was it? This media pipe?
Media pipe, I believe it's two main I need to double check.
I mean,
But
is Pose like PoseNet and they have different nets?
yeah, it's a like 2 KNN, but they also I would need to look more into it. It also because they have a lot of different models, but yeah, I need to look more into that. Yeah, but I believe yeah they separated into like a first KNN to like extract the actual hand, and then from there um they do a similar thing to get the hand landmark positions. Yeah.
Will your software help out the hearing impaired as a translation tool to and from sign languages? So I guess the idea is somebody signs, and then instead of having text to speech, you have sign to speech. You may have to augment it a bit. Many signs rely on additional face gesture. So you might have to have some face key point detection as far as the face gesture to go along with a hand gesture. So it may be something that you have to get some faster processor on it or some good speed up. But it seems like that would be a good translation, kind of like Google Translate for sign language.
Yeah. I don't know much about sign language. I also know it like relies on um information on like spatial data, for example, stuff over your head, on either side of your body. I know that I know similar tools exist for sign language. MediaPipe, essentially with their hands in face model. I think the face model also gives data on like position. It should be possible. I don't know how many sign language sort of like symbols or signs there are, but I know similar things exist, so that they must have found something. Yeah. And then I also think MediaPipe has the at least some other tools are work with Android. I think iOS too. Um, so it it would work on like phones and tablets, which is definitely an interesting thing.
Just from a quick search online, it looks like there's 26 letters for sign language, but also I'm finding things like 1,000 words to sign. So at the
Yeah.
word level. So then it would get to be a discrimination difficulty of trying to discriminate between things that are similar words.
Mhm.
But there might be some common set that it says it does recognize versus not to kind of set expectations.
Yes. Yep.
Okay. If there's No other questions. Tom or anybody at ACM, did you want to make any other announcements? We also have other science fair winners on another winner talk on YouTube. And we have the various upcoming ACM talks. They should be posted on the meetup site as well.
Well, thank you. Yep.
Okay. Yeah, it's been a good project. Thanks for presenting it. So about how many person hours do you think you put in on it?
Oh, that's a tough one. Too much. Probably. Maybe around 100. Maybe, yeah.
Okay.
I went through multiple iterations and yeah. Yep. Well, thank you. Yep.
Okay, well, thank you very much. And I think we can go ahead and close down this meeting unless there's anything else. Thank you very much and have good luck going forward. SR says that as well.
Yep.
So it sounds like you have a lot of good directions to go in. So, okay,
Yep.
thank you and goodbye.
Thank you.